Okay, I'm going to go through the circuits portion of the interim study guide. So we've got students that were given a battery, a switch, and 2 light bulbs. And so one group one, built a series circuit like so, and another group built a parallel. So we can see we've got our multiple pathways here. And they're both looking at the brightness of the bulbs. So both circuits have the same components. They've both got a battery, they've got 2 bulbs, and then they've each got a switch. So we want to know which observation is correct. So brightness of the bulbs in both group circuits would be the same since the current is the same. We know current is got different rules between series and parallel. Okay, so we're going to X that one. The brightness of bulbs in group 1 circuit would be brighter than in group 2's since the total current in series is greater. Okay, so if we think back to our rules, series current is just, it has the same value throughout the whole circuit. Okay. For parallel, every time you add a pathway, you add more current. So generally, parallel has a greater current value than series. With series, every time you add another resistor or a bulb, you're actually going to decrease your current. So we'll X that one. We'll look at 4. The brightness of the bulbs in both group circuits would be the same since the voltage is the same in both circuits. So the batteries here, I mean, they look like they're the same. I don't know for sure if they're the same. But voltage, again, is another thing where the rules are different between series and parallel. Okay, so it's not necessarily going to be the same. So observation 3, the brightness of bulbs in group 1's circuit would be dimmer than in group 2's since the total current in series is smaller than in parallel. That's the one that we're going to choose. And remember when we did labs, if we added more bulbs to a series circuit, the remaining bulbs got dimmer. But with parallel, as you add more bulbs, the others stay the same brightness because you're just adding to your overall current by adding more bulbs. Okay. All right, which of the following answer choices best describes the voltage and current flowing through the resistors in circuit A and circuit B? So this is circuit A, and this is circuit B. So circuit A is a series circuit. B looks like a parallel circuit. So let's see. In circuit A, the voltage across all 3 resistors is the same, but the current is different. So with series, each of these resistors is going to have they're going to have the same current value, and they're going to have a different voltage value because of the rules of series circuits. Circuit B, the voltage is the same, but the current is different. So let's hang on to that one for a minute. In circuit A, both the voltage and current are the same. Again, we said that voltage is going to change per resistor. Current will be the same, but voltage is going to change. So we'll X that one. In B, voltage and current are the same. With a parallel circuit, your voltage is all the same, but each pathway has its own current value. So each of these pathways is going to have a different value for current. So we're going to end up with choice B here. In circuit B, the voltage is the same. That's one of the rules of parallel circuits, but the current is going to be different between the pathways. A physics student builds a circuit. So again, another circuit with a battery, wires, and a switch and 2 bulbs. Which element should they add to cause the bulbs to dim but not go out? Okay, so these are circuit symbols. We talked about these. Let's see. So this is a switch. This is an open switch. That would cause, that's a way to shut off the circuit. If you open the switch, you're basically disabling that flow of current around the circuit. So that would cause the bulbs to go out. And then this is just a closed switch, so that really wouldn't change anything. If we put a closed switch in there, the current would just run through it. This is actually a fuse. Fuses we've talked about more recently. They're an item that will prevent a circuit overload or a current overload. They shut down a circuit. So they would, if a fuse was activated, they would turn everything off. This is a resistor. Remember, a resistor is an item that restricts the current flow when we put those into a circuit. So that would cause the bulbs to dim but not go out. That would lower the current going through the bulbs, and so they would be dimmer. But they would still have current because this isn't going to shut off the current. It's just going to lower it. So C. Student needs 4 ohms of resistance to complete a circuit. They only have access to 1 ohm resistors. Okay. And so they want 4 ohms of total resistance. They should do which of the following? Okay, so this goes back to our rules of resistance for circuits. For series, we add up our resistors. So we have R1 plus R2, etc. Parallel, that's the one where every time you add a resistor, you're actually decreasing the resistance because you're giving yourself more pathways. So you're increasing your current and decreasing your resistance. So that's the one with 1 over R1 plus 1 over R2, etc. Okay. So if we just want 4 ohms of total resistance, we have 1 ohm resistors. The easiest thing to do would be to just add 4 1 ohm resistors and then in series, because then that'd be 1 plus 1 plus 1 plus 1. That would give us 4 ohms of total resistance. If we added 4 1 ohm resistors in parallel, then we're going to get 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. We're not going to get enough resistance if we do that one. Same here. We'll just get, again, we're not going to get enough. And then if we combine them, we're still not going to get enough. This is the way to get all 4 ohms of total resistance that we need. It's just to connect them all in a series circuit because they add up. Student makes following claim about electron flow through a circuit that includes a battery and a bulb. The current through the circuit is called alternating because the electrons move from the negative side of the battery through the circuit to the positive side of the battery. What is incorrect about the student's claim? So in this case, they're talking about just doing like a regular little circuit here with a battery and a bulb. Okay. So this would be like a series circuit. We've got a battery, so that tells us that we are getting a direct current because the battery is a source of that. And our electrons will go from the negative side to the positive side as they go around the circuit, but they're just going to go around in one single loop. Really what the student's done here is they're not describing alternating current correctly. Alternating current goes back and forth. The electrons reverse direction. And an alternating current would not come from a battery. We've talked about that before. It comes from a bigger source like a generator or a power plant. All right, we've got another side to talk about on circuits, so I'm going to continue that in the next video.